Hello 172 class, welcome to the fourth lecture of the semester. What we're going to look at this time is angles in standard position and rotating off of standard position. So what we talked about before, when we had a radius of 1, there was always this one-to-one correspondence between the arc length, what we used S, and the radius itself. So the question is, well, what if the radius is not 1? Well, the adjustment's not that bad. That angle measure, the radian measure, is no longer just the arc length, but it's the arc length divided by the radius. So remember, if the radius was 1, the angle in radians is the arc length, so theta equals S. But now it's just if the radius were, for instance, 2, then the arc length would have been 2. When we were at 1 radian, we showed the arc length when this was 2, and this was 2. 2 divided by 2 was 1, that was 1 radian. So the quick fix is if the radius is not 1, instead of the radian measure being equal to the arc length, it's just the arc length divided by the radius. Alright, and then from that we get the very important formula for trig and even into calculus for those going into calculus. If we want to know what the length of a circular arc is, all we need to know is the radian measure. It's very, very, very important that you understand that theta there is not just any old theta, it has to be in radians for this formula to work. So it's the radian measure of that angle times the radius, and that's our arc length. It's a very easy formula, but it does become important. Now this is why it's important. Find that a circle has a radius of 10 inches. Find the length of the arc intercepted by a central angle of 120 degrees. Well, if it's 120 degrees, that's not radians. So I can't use this formula yet. So I have to make sure to convert it to radians before I do it. So 120 degrees, we learned in the last video, I can multiply that by pi over 180, and that ended up being 2 pi over 3 radians, and now I can use the formula. The circle has a radius of 10 inches, so that's R. That's 10. And now theta, we know theta in radians. The radian measure is 2 pi over 3. So what is the arc length? The arc length is 10 times 2 pi over 3, which can be simplified to 20 pi over 3. And that would be inches. Alright, the same units as the radius. Okay, so that's just an example of how we can go through and find the arc length if we know the angle in either measure. If it was already given to us in radians, we'd plug right in. If it's not, then that quick switch from degrees to radians like we saw in the last video, and then plug it in. Alright, now on to what we were talking about at the very beginning, standard position. Standard position is your initial side of the angle you're going to create is on the positive x-axis, and then the terminal side where you end up after rotation, after you rotate by an angle, is what we call the terminal side. Let me blow these up a little bit so you can see them a little better. If we go beyond 180 degrees or pi radians, then we get an improper fraction out there in front of pi. If we have not gone 180 degrees, then we'll end up with a proper fraction being multiplied by pi, like 1 pi over 4, 1/4. Right? And then anything less than rotating to the y-axis, pi over 2, like we saw before, is what we call a acute angle. So anything like pi over 4, pi over 6, pi over 3, all the way up to pi over 2, or 1/2, being multiplied by pi, those are what we call acute angles. Alright, now, both of these angles that we're drawing, we are rotating positively, meaning the angle of rotation is from the positive x-axis up towards the y-axis. Alright, and in this one we went up towards the y-axis and then kept rotating down past the x-axis. We could also rotate clockwise. We could rotate in this direction, and that would be a negative. I mean, I actually did the colors exactly backwards in words up there. So this would be a negative rotation, would be going back this way. Alright, if I rotated to something, that would be like a negative angle. let's say that's negative. There's pi over 2. So like negative 2 pi over 3. Something like that. Alright, and then there's positive pi over 4. That's a positive rotation because we're going up off the x-axis instead of down below the x-axis. Alright, so there's just another example of going down. Rotating clockwise is actually a negative angle. Counterclockwise is positive. Alright, just think if I'm going from positive x to positive y, that way, positive x to positive y, that's a positive angle. Alright, now this is something I'm going to show you the slide, but I strongly encourage you to do this yourself. On Moodle, you will find a blank unit circle, and all of these values are missing. Like, you don't know what these angles are. Okay? And I strongly encourage you to go in there and do this yourself. Meaning, I'll show you just with this first quadrant here. Take a second and know it's going to be 30, 45, and 60. Alright, so 30 is the smallest angle, 45 is the next biggest, and then 60 is the biggest. And then convert these to their radian measure on your own. So multiply by 180 over pi. Anyway, you'll end up with pi over 6, pi over 4, and pi over 3. But do that for all the angles on here, and then do it in their negative direction. Just for practice, because again, it's going to be very important. But the thing I want you to see is very important that you watch, and listen really closely what I'm saying right here. What you're going to see is once you get to 90 degrees, all you're doing is you're just adding these three numbers again to 90. So 90 plus 30 is 120. 90 plus 45 is 135. 90 plus 60 is 150. Right? And then it's another multiple of 90. 90 times 2 is 180. And then when you get to 180, you're going to add 30, 45, and 60. Right? 180 plus 30, 180 plus 45, 180 plus 60. Right? And then it's another multiple of 90. 90 times 3 is 270, and then 270 plus 30 plus 45 plus 60. And then finally, all the way back, that's 0 degrees. It's also 360 degrees. Alright, and it's also what we call 2 pi radians. So it's important for you to be able to do it clockwise, counterclockwise, and positive and negative angles. Okay, it's important because some things rotate clockwise, some things rotate counterclockwise. So we're going to need to be able to do it with positive and negative angles. So it's very important. I would strongly encourage you to do this exercise on your own, where you create your own unit circle. All right, and you're going to hear me again. I said in the first video, you're going to hear me refer to the unit circle a lot. One of the things that you're going to be able to use in my calculus courses anyway, when you take calculus from me, is your own unit circle, and you can make little notes on this thing. Right? It's very, very, very important to trigonometry and to calculus that you understand the unit circle and you understand what we call the special angles. Right? What we see on this slide right here, these are the special angles, and they're special because they just show up a lot when we do some of the stuff that we do in tree, but also carpenters use 45s and 90s and a lot of these angles. Plumbers, these are very useful angle measures, and likewise they're going to be important, very important for our study.